Hey, I'm Mitchell. Welcome to another video in the RSP education series. In industrial automation, temperature sensors aren't just accessories, they're frontline defense against costly downtime, product loss, and even dangerous failures. In this video, we're diving deep into the world of temperature sensors from RTDs and thermocouples to thermistors and infrared tech. Whether you're designing a system, troubleshooting equipment, or just want to sharpen your edge in automation, this breakdown is going to show you exactly how the right sensor can make or break your operation. Stick around. By the end, you're going to know exactly which sensor fits your application, how to pick the right one every time. If you like this kind of content and want more educational videos, please like and subscribe. Also, this video is for educational purposes only. Consult a professional for your application. RSP Supply is not liable for any misuse of this information. With that said, let's get into it. So temperature sensors in industrial automation, they're essential tools that detect the temperature of machines, systems, or environments and convert that measurement into an electrical signal. That signal feeds directly into control systems like HMIs, human machine interfaces, PLCs, programmable logic controllers, or SCADA systems. By translating temperature into a readable value, automation systems can monitor conditions in real time, make adjustments automatically, trigger alarms, or record historical data for analysis. There's different types of temperature sensors. First, we'll discuss RTDs, or resistance temperature detectors. Here's how they work. RTDs measure temperature by tracking changes in the electrical resistance of a metal as it heats up. In industrial environments where consistency is key, RTDs offer a highly predictable and reliable way to monitor process temperatures. The materials used in an RTD primarily is the platinum is a preferred material because of how accurate it is, its repeatability, and its resistance to corrosion. Very important for long-term performance in industrial settings. RTDs are also highly favored because of their accuracy and stability. They provide very high accuracy and long-term stability, which is critical for industrial processes where even small temperature variations can impact product quality or system performance. You'll find RTDs in automated production lines, chemical processing plants, and clean manufacturing environments where maintaining strict temperature control is a must. Now let's talk thermocouples. The way these work is they generate a small voltage when two different metals are joined together and exposed to a temperature difference. That voltage that's created is then interpreted by industrial controllers to determine the temperature. Its temperature range is a big plus. Thermocouples are valued for their ability to measure extremely wide temperature ranges from cryogenic processes all the way to high heat industrial ovens and furnaces. They have very high response speed and high durability. Their ruggedness and quick response times make them perfect for dynamic industrial applications with extreme temperatures, vibration, or mechanical stress. You'll often see thermocouples in automation systems, monitoring boilers, gas turbines, heat exchangers, and metal forging operations where conditions are too harsh for any other types of sensors. Thermistors is a different type of temperature sensor. They work by using ceramic materials to detect temperature changes by observing large shifts in electrical resistance. The quick response times are ideal for precise control. Different types of thermistors, there's two basic types. You have NTC, or negative temperature coefficient, which means that the resistance decreases as temperature increases. Then you have PTC, or positive temperature coefficient, where resistance increases as temperature increases. An interesting fact is thermistors' nonlinear behavior. Since they have a nonlinear resistance curve, automation systems often need to have special calibration or signal conditioning to integrate their output into control logic effectively. You'll see these used frequently in thermistors, that is, in areas or applications where there's tight temperature control, like battery management, environmental chambers, or cooling systems and control panels. Then you have infrared temperature sensors. They work by infrared, obviously. IR sensors are going to measure the infrared radiation that's emitted by objects. It then calculates the temperature without any kind of physical contact. This makes them perfect for non-invasive temperature monitoring in automated processes. So because of their non-contact measurement, infrared sensors are especially valuable when measuring moving parts, hazardous areas, or surfaces that can't be touched during operation without stopping the process. They are also very high speed. Because they provide instant readings, IR sensors help automated systems make rapid adjustments to keep operations safe and efficient. You'll see infrared sensors used very commonly in monitoring conveyor belts, heated rollers, electrical panels, or high-speed manufacturing lines where fast temperature feedback is crucial. For example, an infrared thermometer might monitor the surface temperature of a motor housing during production, feeding real-time data into the automation system to prevent overheating. Temperature sensors, they may be small, but their impact on industrial automation is massive. We covered RTDs for precision, thermocouples for extremes, thermistors for fast response, and infrared sensors for hands-free accuracy. Choosing the right one isn't just about temperature, it's about control, safety, and performance. For a full line of sensors and hundreds of thousands of other industrial automation products, please go to our website. That's rspsupply.com, the internet's top source for industrial hardware.